Welcome back to our learning session. This time, what we will talk is all about computations of the series and parallel connections. And the objective of this lesson is for you to be able to calculate current, voltage, resistance for the total circuit or any load in an electrical connection. And to solve problems regarding circuit connections, we will use the Ohm's law. This law was explained by George Ohm, where he stated that the current flow through a conductor is directly proportional to the potential difference or voltage and inversely proportional to the resistance. And it is equated as I equals to V divided by R. So this equation simply shows that the current is directly proportional to the voltage and it is inversely proportional to the resistance. So therefore, if we increase the voltage, the current will also increase. And the same thing will happen if we increase the current, the voltage will also increase. Therefore, if we increase the current, the resistance will decrease. And the decreasing of resistance will result to the increasing of current. In this equation, the I is the symbol for current, and the unit for current is ampere with the symbol A. The V is the voltage, and the unit of voltage is volt with the symbol V, and the R is the resistance with a unit of ohms. So to find equations on how to solve the unknown variable for series and parallel connection according to Ohm's law, we will use the what we call Ohm's law triangle, which shows that if the unknown variable is the voltage, we will simply multiply the current and resistance. Then if the unknown variable is current, we will divide the voltage and resistance. And the same thing goes if the unknown variable is the resistance, we will divide the voltage and the current. Another important thing to remember in computing series and parallel connections is the rules of series and parallel. Remember these equations shows the rules of the series and the same thing with the rules of the parallel for the current, resistance, and the voltage. So to understand the concept between the series and parallel connections, please watch the first part of this video. So let's now have an example for series connections computation. Three resistors having a value of 2 ohms, 4 ohms, 6 ohms are connected in series to a 6 volts tri-cell. So solve the following. Resistance of the combination, current through the combination, current in each resistor, and voltage across each resistor. So let's identify first the given in this problem. So the given are, we have the resistance 1, which is 2 ohms, the resistance 2, which is 4 ohms, the resistance 3, which is 6 ohms, and the voltage, which is equivalent to 6 volts. So now that the givens are identified, let's now find the first unknown variable, which is the resistance of the combination. So to find that, we will use this equation as the rule of the series connection for the total resistance. So simply add the value of the three resistors. So we have the value for resistor 1, which is 2 ohms, the value for resistor 2, which is 4 ohms, and the value for resistor 3, which is 6 ohms. That will result to 12 ohms. And the 12 ohms is the total resistance for the problem. So meaning 12 ohms is the resistance of the combination of the resistance in this series connection. So now the updated givens are total resistance equals to 12 ohms and voltage equals to 6 volts. Let's now find the second unknown variable, which is the current through combination or simply the total current. So in here, remember that in series connection, the total current is equal to the individual current in the series connection. And for us to find the value of current, we will use the Ohm's law triangle, which shows that to find current, we simply divide voltage and resistance. So let's substitute the given to the formula for us to find the total current. So we have 6 volts, divide it to 12 ohms. Then, therefore, the total current is 0.5 ampere. Now for answer in unknown variable for letter C, which is referring to the current in each resistor, we will follow this equation as the rule in series connection. So if the total current is also the same as individual current, therefore, each of the current has 0.5 amperes. Since we now have the value of total current, let's now solve for the fourth and last unknown variable, which is the voltage across each resistor. But again, remember the rule in series connection for the voltage, which is the total voltage is equals to the sum of individual voltage. So to solve for the value of voltage of each of the individual resistor have, let's use the Ohm's law triangle, which shows that to find the value of voltage, we will simply multiply current and resistance. So let's find the value of voltage one by one. So to compute the voltage 1 for resistor 1, simply multiply 0.5 ampere and 2 ohms. So that will result to 1 volt. Then, to find the value of voltage for resistor 2, simply multiply 0.5 ampere to 4 ohms. Then, that will result to 2 volts. And lastly, to find the third voltage for the third resistor, we will simply multiply 0.5 ampere to 6 ohms. Then that will be equal to 3 volts. So these are now the value of the voltage across each of the resistor. Now, to find the total voltage for this connection, we will simply add these values that will result to 6 volts. So meaning the total voltage for our series connection is 6 volts. So let's now have an example for parallel connections. In here, 3 resistors with a value of 2 ohms, 4 ohms, 6 ohms are connected in parallel to a 6 volts dry cell. So solve for the following: resistance of the combination, current through the combination, current in each resistor, voltage across each resistor. So let's identify first the givens. In these problems, the givens are resistance 1 equals to 2 ohms, resistance 2 equals to 4 ohms, resistance 3 equals to 6 ohms, and the voltage which is equal to 6 volts. Then after identifying the given, let's now solve for the first unknown variable, which is the resistance of the combination, or simply the total resistance. So remember the rules in parallel connection that the reciprocal of the total resistance is equal to the sum of the reciprocal of the individual resistance in the connection. So simply substitute the given to the formula. So we have the resistance 1, which is 2 ohms. We have the resistance 2, which is 4 ohms. And we have the resistance 3, which is 6 ohms. So simply divide 1 to each of the value of this resistance. Then we will get 0.5 ohms, 0.25 ohms, and 0.17 ohms. Then add these 3. So if we're going to add that, the answer will be 0.92 ohms. And since we have here a reciprocal of total resistance, simply divide 1 to the 0.92 ohms. Then the answer will be 1.09 ohms. So this is now the value of the resistance of the combination or the total resistance in our parallel connection. So let's now move on to find the second unknown variable, which is the current through the combination or the total current. Remember, in parallel connection, the total current is the sum of the individual current. So we will find first the individual current using the Ohm's law triangle, which shows that to get the current, simply divide voltage to resistance. Another thing, in parallel connection, the total voltage is also the same as the value of individual voltage. So it means that all of the resistors here are having 6 volts as voltage. So let's now solve for the individual current by substituting the value of individual voltage and resistance from our formula. So in finding current 1, simply divide 6 volts and the value of resistance 1, which is 2 ohms. That will be equal to 3 amperes. And to get the value of current 2, simply divide 6 volts to value of resistance 2, which is 4 ohms. And that will be equal to 1.5 amperes. And to find the current 3, simply divide 6 volts to the value of the third resistance, which is 6 ohms. So that will give us 1 ampere. And for us to find the value of total current or the current through the combination, add the 3 values that we get. So 3 amperes plus 1.5 amperes plus 1 ampere, it will be equal to 5.5 amperes. So that is the current through the combination or the total current. And to answer the unknown variable in letter C, which is the current in each resistor, we already solved that. So here are the values. For current 1, we have 3 amperes. For current 2, we have 1.5 amperes. And for current 3, we have 1 ampere. So since we now have the value of the total current, let's now proceed to the fourth and last unknown variable, which is the voltage across each resistor. To find that, remember that in parallel connection, the value of the total voltage is also the same as the individual voltage. So to find the value of this, we will simply use the formula in Ohm's triangle, which shows that we simply need to multiply the value of the total current to the value of the total resistance. So let's substitute that. So we have the total current, which is equals to 5.5 amperes, and we have the total resistance, which is equals to 1.09 ohms. Then if we're going to multiply that, the product will be 5.05 volts. So that is the total voltage of our parallel connection. You know what? It is also possible for us to combine the series and parallel connections. So let's have an example. Two resistors which have a value of 2 ohms and 4 ohms are in parallel with each other and are connected in series to 10 ohms resistor. So solve the combined resistance and the total current in the circuit if it is connected to a 110 volt source. So in this problem, what we need to find are the combined resistance and the total current in the circuit. So let's identify first the givens. The givens are resistance 1, which is 10 ohms, resistance 2, which is 2 ohms, resistance 3, which is 4 ohms, and the voltage, which is 110 volts. So in series parallel connections combination, we need to identify first which is the parallel connection and which is the series connection. So in our example here, the parallel connections are the R2 and the R3. Okay, and the series connection is referring to the R1. So now we already identified which is the series and parallel. We can now move on in solving the unknown variables. So the first thing that we need to do here is to find the total resistance of the parallel connection. So remember that in parallel connection, the total resistance have a reciprocal and it is equal to the sum of the reciprocal of individual resistance. So in here, we just simply need to substitute the given to the formula. So we have the resistance for resistor 2, which is 2 ohms, and the resistance for resistor 3, which is 4 ohms, since both of them are connected in parallel connection. So in here, what we need to do next is to get the reciprocal of this individual resistance, which will be equal to 0.5 ohms and 0.25 ohms. Then the next thing that we need to do is to get the sum of them. So the sum will be 0.75 ohms. Remember that the total resistance has a reciprocal. So we need to divide 1 to 0.75 ohms, and that will be equal to 1.33 ohms. So that will be the total resistance in our parallel connection. And then, since we only have one resistor for our series connection, we can now simply combine the value of the total resistance for parallel connection and the value of the resistance in the series connection. Okay? So, to get the total resistance, simply get the sum of them. Then, let's substitute the given to the formula. So we have 1.33 as the total resistance of our parallel connection and 10 ohms as our resistance for series connection. Then if we're going to add them, the total resistance of these series parallel connections is 11.33 ohms. So we are now have an update givens, which are the total resistance of our connection, which is equals to 11.33 ohms, and the voltage is equals to 110 volts. So let's now solve for our second unknown variable, which is the total current in the circuit. So we will use the Ohm's law triangle in solving the total current in our given circuit. So simply divide voltage to the value of the total resistance. So let's substitute the given to the formula. So we have the total voltage, which is equals to 110 volts, and the total resistance of the circuit, which is 11.33 ohms. Then, if we're going to divide them, the answer will be 9.71 amperes. So that is the total current of our series parallel combination connections. Now that you learned both the concepts and calculations of series and parallel connection, you can now able to create your own series and parallel connections or the combination of both.